Okay, here we have our last section of chapter or unit 3. We're going to talk about present value investments. Last section talked about future value. Now we're going to talk about present value. I'm going to jump right into examples because it's really just using the formula we've been using, the compound interest formula. So, read through example 1, use the compound interest formula to see if you can solve this one. Alright, so here we have, they're going to invest, they want to know in 6 years, so they're going to have money in there for 6 years. They need $20,000 for the first year's tuition, and it wants to know how much they should put into an account with 5% interest. Compounded annually, how much deposit? What you're looking for, how much deposit? So you're looking for their principal. So here's your compound interest formula. Balance equals principal times 1 plus rate over number of times compounded, all raised to the n, number of times compounded, times number of years, t. So this is what you're looking for right here. They want to know their principal. So we can just substitute this all in. 20,000 is how much they want to have. You're going to try to find your principal. The rate was 0.05. Number of times compounded, well, it's compounded annually, so that's once a year. Time, how many years? 6 years. Okay, so you can do this out. When you solve this for P, you should get approximately $14,924.31. Okay, so they need to put in 14 this year, right off the bat. They need to start with $14,924.31 at least into this account in order for them to have enough in 6 years. As you can imagine, this is a very common question. People want to know how much they need to start with in order to end at a certain amount. Or buy a house, how much do I have to put in so that into this account so that in 10 years I can buy a house for $100,000 or $200,000. Okay, so since this is a common application, we really use this formula. This is a formula you're going to want to add to your notes. P, the principal, is equal to the balance that you want over 1 plus r over n to the nt. Basically what we did was we took this formula right here and solved it for P. So that way it makes the math a little easier. You don't have to move anything to the other side of the equation. Okay? So let's try example 2. Read through this and pause the video. Alright, so for this example, we have this lady who wants to graduate from college. She just graduated. She wants $100,000 in her savings account after 10 years. Maybe she's buying a house. How much must she deposit in that account at 3.8% interest rate? So here, underline our important things. This is, she wants $100,000. That's the balance she needs. 10 years is my time. 3.8 is my rate. So this gives me a rate of 0.038. It's compounded daily. So that means that n, number of times it's compounded in the year, is 365. Okay, I think we have everything. So we could put it in our compound interest formula, or we can use our new formula, which is our present value formula. So we want to know how much they have to put in now to get this certain balance here, this 100,000. So I'm rewriting this formula so that you can see it a few more times. Make sure you add this formula to your notes. Alright, so in order to get 100,000, how much needs to be invested? So 100,000 is my balance, and I'll just do my rate over the number of times it's compounded a year, 365 for this daily, and my time is 10 years. Okay, when you do all this math, you end up with about, well, $68,387.49. So that means she must deposit $68,388. So it's the nearest dollar. Take the nearest dollar. Make sure you read through your questions. You hate to have you lose points because you don't round in the right spot. That's the worst. All right, we got a few more examples here. Let's try example 3. I want you to try this, so make sure you pause this video. I should see the time that you have this open should be much longer than the time the video is. Okay, this one is a little bit tougher. I have to go back to the formula that we referenced with the where he said depositing regularly. So you have to kind of go back to last section. But just to refresh your memory, that equation looks like this. So this is if you're putting a certain amount in over time. Okay, so you're going back to this equation, and you're solving for P. Now to make things simpler, if I was to take this equation and solve for P, this is the variation of what that equation would look like. So that's when I multiply both sides by r over n. Okay, so if I was solving this equation for P, this is what it would look like. Again, a very common equation. Okay, so I want to know present value. So I want to get rid of this, make some room. So 3 years, that's my time. 15,000 is my balance. How much you must deposit is my P, principal, present amount, into an account that pays 4% interest, so my rate is 0.04. Compounded monthly, so that means that my N is 12 times a year. And I want to round up to the nearest $100. So in substituting into that formula, I have balance 15,000 times rate over n number of years compounded, or number of times compounded in a year rather. And 3 years. If you do the math on this, you should get, I'm going to round it, so 392.86. That means to the nearest $100, it would be $400. So you must deposit $400 every month, so that in 3 years, he has $15,000 that he needs. Okay? So make sure you put this in your notes. This is present value with regular deposits, depositing it in regular or periodic deposits. So This is present value. It's different from the one we just did prior to this question of a periodic deposit investment. Okay? Again, that's if you're depositing regularly. In this case, this gentleman was depositing every month. Okay? The one prior to this was just the present value if you put in one deposit and you let it sit there. Okay, know the difference between the two and when to use them. Try example 4. Okay, so again, we have the periodic investment. And when you're reading through this, how much to periodically deposit. That's how I know I'm going to use this formula back here. P equals B, this one right here. See that? Periodic deposits. All right, so he wants to have saved $200,000. So this is his balance he wants. 4.5% APR, so that means that gives me a rate of 0.045. Okay. Compounded monthly, so that means N is 12 times a year. There's 12 months in a year. And he wants to know how much he has to put in. And we want them all from 12 months to 240 months. All right, so this one's a little bit different. We are using the same formula though. R over N, 1 plus R over N to the NT minus 1. Now I am going to substitute in what I have. The only thing that's missing right here is the time, and because it's talking about a variation of time, I'm going to actually use a variable to see where it would stand at certain time frames. So over here I'm going to put an X because I don't know my time. Okay, so this becomes my independent variable. And if you graph this, you'll get a graph that looks like this. Okay, and since we're talking about this, present value would decrease as the number of months go up. So this would be the months. And this is the dollars, the amount. Okay, 24 would be a lot higher than 240. So what does this mean? This means that as the number of months goes higher, if he's going to sit this into account for 240 months, he only has to deposit this much right here. Right? If he only wants to put this money in for 24 months, then he's going to have to put in this amount, which is a much higher amount. So, and that should make sense. If you're going to let it sit in an account longer, then you don't have to put in as much every month. Okay? All right, you should be all set for this homework. This is the last section, so make sure your notes are sound and the best and understandable, because they are going to use those as a reference. We will be having a test. Hopefully, if you're having this in on time, you'll have a test in 2 days. So make sure you study and look at the review. There will be a review. Good luck.